In this video, let us see about nodal analysis. Now, let us see the steps involved in nodal analysis. Let us take this circuit. First step is you have to identify all the independent nodes. So, what is a node? It is a junction of two or more components. So, here one is a node and this point 2 is also node because two resistance and one current source are connected together. And if you see the bottom here, all the elements are connected to a single point only. There is no resistance here. So you can take the whole thing as single node. So there are totally 3 nodes. 1, 2 and 3. Now you have to identify one as a reference node. That is, it is similar to the ground pin in our circuits. So that will be at zero potential. It is necessary to identify the reference node because we will be writing the equation with reference to reference node. So let me mark the nodes. So this has V1 and this has V2 and this is 0 volt. So there is no need to label it. It is the reference node. So after identifying the node, you can write the equation for each node. So totally you have only two nodes, V1 and V2. This is reference node. So there is no equation for this one. Just you need two equations to find the two variables V1 and V2. Now we have to apply the Kirchoff's current law at the nodes. According to Kirchoff's current law, at any node, the sum of the current entering the node is equal to sum of the current leaving the node. So we have to mark the current directions. So you take this node, you mark the current direction as like this. That is, all the currents are leaving the node. Okay. So whenever you have a voltage source or if the resistor is connected to the reference node, you can mark the direction as like this. That is, the current is leaving the particular node. If you take this node 2, here you have a current source. So the arrow is already given. So this 4 amps is entering the node. Whereas this resistor, I have taken it as it is going out of the node. Okay. So next we have to write the equation for each node and find the variables V1 and V2. Always remember the Ohm's law, V is equal to IR, because for writing this equation you need Ohm's law, V is equal to IR. Okay, now let us solve some problems using nodal analysis. So you take this circuit, the question is you have to find the voltage V. Where is V? It is here across 10 ohms. So you have to find what is the current through the 10 ohms and multiply it, you will get voltage, or you can find the potential across this one. Okay, by any method you can find this one. So you see here, first step is identifying the nodes. So you mark the nodes here. In this case, there are only two nodes. So you see here, all the elements are connected to the single point. Similarly, in bottom side also, all the elements are connected to the same point. So this point, I can take it as reference node, and this is labeled as V1 or V. Anything you take it. Okay, so you need to write only one equation because the second node is a reference node. Now we will apply the Kirchoff's current law. So you mark the current directions. So first 5 amps is entering the node. For 10 ohm resistor, I am assuming it is leaving the node. 1 amps is leaving the node. and this 10 amps current is leaving the node, and in this 6 amps current is entering the node. Okay, so if take V1, what are the currents entering the node? This 5 amps is entering and this 6 amps is entering. So the sum of the currents entering the node is 5 plus 6. So this should be equal to sum of the current leaving the node. Okay. So how to write the equation here? So what is current? I is equal to V divided by R. You see here I is equal to V by R. So I am writing V1 minus 0, that is reference potential. So V1 minus 0 divided by 10 is the current through this branch. Okay. And what is the current in this branch? 1 amps. So it is plus 1. And what is the current in this branch? V1 minus 0 divided by 10. So if you solve the equation, you are getting 50 volts. So this 50, V1 is equal to 50 volts. V1 and V are same. So the answer is 50 volts. Now let us take the second problem and write the nodal equation. Okay. So here again we are identifying the nodes 1 and 2, and this is the reference node. Okay. So mark the nodes V1 and V2. Now we have to mark the current direction and write the equation. So let us take first node 1. At node 1, this current is leaving the node, and this current is leaving the node, and this current also leaving the node. So how to write the equation? So for this branch, the current is, because you have a voltage source here, so you cannot write V1 minus 0. Actually 20 volt is here. So you write it as V1 minus 20 divided by this resistance 5 is the current through this branch. What is the current through this one? V1 minus 0 by 10. And here it is another node is here. So you have to write V1 minus V2 divided by 10. So your nodal equation will be sum of the currents. Here all the currents are leaving the node. So sum of the currents should be equal to 0. So first V1 minus 20 by 5 plus this current is equal to 0. Now let us write for node 2. So at node 2, you see this 4 amps is entering the node, whereas the remaining two currents are leaving the node. And similar to a mesh equation, when you write for node 2, okay, you have to write V2 minus V1 by 10. The same thing we will do in mesh analysis. When you write for second loop, you will write I2 minus I1. And when you write for first loop, you will write I1 minus I2. Similar to that, when you write for node 2, you write it as V2 minus V1 by 10. And for this branch, it is V2 by 20. So here two currents are leaving the node. Add those currents, that will be equal to the current entering the node, that is equal to 4. So if you solve the equation, you will find what is V1 and V2. So in the question, it is asked to write the equation alone. So I stopped here, but you can solve the equations and find what is V1 and V2. Next, we will find another problem where you have to find the current through the 3 ohm resistor. So if you see this circuit, 3 ohm resistor is here. We have to find the current through this one. So mark the nodes V1, V2 and this is 0 reference node. Now we will apply the Kirchoff's current law, mark the current direction and we will write the equation. So here take node 1, 5 amps is entering the node and here it is V1 by 10. Actually V1 minus 0 by 10. So I have written as V1 by 10 plus V1 minus V2 by 3. So we have written the first equation. Let us simplify this equation. Okay. So just V1 take the common terms 1 by 10 and 1 by 3 minus V2 into 1 by 3 equal to 5. You can do this calculation, you will get this one. Okay. Now let us write the nodal equation 2. So take the second node, you write the equation. First this is V2 minus V1 by 3, V2 by 5, V2 minus 10 divided by 1 equal to 0. So while writing this equation, you should be careful whether it is plus 10 or minus 10. When you have a plus symbol at the top and if you write like this, it is you are writing V2 minus 10. Okay. If negative is there at the top and here positive is there, you have to write it as plus 10. That also you have to remember. And you solve this equation. So you got two equations. You solve those two equations, you will get the voltage. So the current through 3 ohm resistor is V1 minus V2 by 3, that is equal to 2.98 amps. That is, it flows from this, flows in this direction like this. So our assumed current direction is correct. That's it. So the points to remember here are: always prefer nodal method when there are current sources. It will be easy. And identify all the independent nodes. Select the reference node. Apply Kirchoff's current law and write the equations and solve for unknown voltages. If you like the video, subscribe to this channel, Read Electric Vehicle channel. And if you have any queries, you just write in the comment section. It will be discussed. These are some of the references which I have followed.